I'm going to talk about free lunch learning, and this is a very strange phrase, and I will explain it to you shortly. No, it's not there. So this all began with an email, and there is a British email statistics discussion list called Allstat. And most of the messages there are not very interesting. But one email caught my eye because the header was hyperspheres. And I thought, if there are spheres, it will be interesting. So I read this email, and it was from somebody asking for help, and I couldn't understand what he was talking about. But I did understand that it involved memory and recovery of memory when memory comes back, and this is somehow spontaneous. It happens without anything helping it. The other thing I understood was that this was a geometrical problem. There seemed to be vectors W1 and W2 and matrices, one matrix, big X1, that acts on W1 and W2, and this should bring these vectors close to some vector D1. So we're looking at squared distances, and we're looking at the difference of the squared distance. The difference of these squares. In the original question, it wasn't squared. So we were looking at the difference between these lengths. Now, these quantities, X1, the matrix, and W1, W2 vectors, and the vector D1 seemed to be not fixed, but random. And so delta would vary, and sometimes delta would be positive, and sometimes delta would be negative. And the man who sent the message wanted to know what was the probability that delta is positive. And I will explain later where these things come from. The other thing I learnt from the message was that the man who sent it was called Stone, Jim Stone. He was a psychologist at the University of Sheffield in England. And that was all I knew. I didn't know what he looked like. I was interested because the email said spheres. And as Dr. Watamori has just reminded you here, spheres are interesting spaces on which to do statistics. And the observations are on spheres of various dimensions. On the circle, such as drawn here, described by angles theta. Or if you like, we can think of the points with coordinates cos theta, sine theta as being vectors in the plane, but they should be unit vectors. Or we can look at observations on the ordinary sphere. I meant to bring one along, but you all know what it's like, of unit vectors in 3 space, and of course we live on a sphere, the Earth. And in general we could work in p dimensions and have a p-1 dimensional sphere. And in general, well, let's ignore this red thing, but the Japanese for most of those words is given on the left-hand side. So it turned out that this psychologist, Jim Stone, was interested in the human brain and how the human brain works. Now, each of us in this room has a brain, and we have very kindly brought them along this afternoon, but we cannot see them, and it's hard to know in general how the brain works. But here is a picture of the outside of a brain, and we know that it consists of a lot of neurons, which I shall call cells, and these cells are connected by sort of wires, and these connections are called synapses. And there are a lot more synapses than there are neurons. There are various ways in which people study the brain. You could, for example, take the brain from somebody who doesn't need it anymore, and you could cut it up and you can see what it looks like. But that doesn't tell you how the brain works. So another thing you can do is put electrodes on the head of somebody and measure the electrical activity. Or you can do medical imaging to see things happening. But the kind of study that Jim Stone in Sheffield does is of rather a different kind, and it can be divided into 4 bits. Anecdotes, in other words stories, and I will tell you 2 stories in a minute, or it can be done by experiment, and by experiment, well, you'll see what I mean, but it doesn't involve putting electrodes on people, it doesn't involve cutting people up. And then for those of us who are mathematicians, we can produce theorems, and those of us who like doing computer simulations can do that as well. So, the main anecdote that I shall talk about involves knowing a foreign language. In my case, almost Japanese. And then I will tell you about an experiment involving a computer keyboard, but it's been scrambled in that the connections have been changed so that when you press a key here, it doesn't give the letter that you expect. And then there are some theorems, and these theorems that I will tell you about involve artificial neural networks, and they involve probability distributions. And I will tell you a little bit about some simulations which were done using artificial neural networks. So, Jim Stone has written several papers with interesting titles. And one of these was called Unicycling Improves Your French. And so here are some people on unicycles, and I gather it's quite a difficult skill, though I did see one of Dr. Watamura's daughters unicycling very successfully a few days ago. And the idea behind this is that if you performance at one skill, like speaking French, something like that, it can be improved by learning something completely different, like unicycling. And the evidence for this is partly through an anecdote, through stories about people who have done some other activity, like learning to play the violin, and it makes them better at other activities, like doing mathematics. There is also evidence from simulations in artificial neural networks.